Hey everybody, Mr. Calbeck back again. It's great to see you guys. Hopefully you can join us today on our Google Meet during class. I would love to see you and just hear how your lives are doing. You can ask me math questions if you want to, but mostly I'm just really excited to see you guys, and I hope that everything's well. And don't be afraid to ask me if you do have questions or you need anything. I would love to help you. So we're going to start today's lesson. The math part of it anyway, just by looking at the bonus question from last time. So this is what I asked you guys to try on your own. I didn't give you the answers. I want you to see what you can come up with and be creative. Because again, what we're going to be looking for here is can we graph any kind of quadratic equation regardless of form? That's really what we're trying to strive for. By the end of this chapter, you will be able to do pretty much anything I could throw at you. So this is kind of the first step of that because I'm not giving you all the information. So I gave you a couple of hints though, and this was something we worked on before spring break. So if it's a little bit familiar or you're able to figure it out, good job. I'm really glad you remember that. If not, it's been 2.5 weeks, so don't feel like you're doing something wrong here. If you're struggling with this, that's okay. So if you want to graph a parabola, I mean, there's some key points anytime you want to do something, right? So if you've got a parabola here, and I don't know what this one looks like yet. I do know what it looks like, but let's just say that I have a parabola and it's over here, right? There's a couple of key points that you're going to need to be able to figure out with any parabola. X-intercepts, those are really important, right? That's where it crosses the x-axis. So those are really helpful. You get those from factored form. So if you could factor this, you could find your x-intercepts. So let's start with that one. This is the easy kind of parabola. Remember when it has a ninja 1 in front of the x squared, you don't have to do any fancy stuff with the rectangle. You always can. Rectangle always works, but you don't have to use it in this case. All we really need to do is figure out what multiplies to be -15 and adds to be -2. And hopefully you came up with the right answers. And again, you could have done this with the rectangle or just with your head. We know one's negative and one's positive because it multiplies to be a negative. And I know that the 5, it's 5 and 3, 5 has to be negative because it adds to be -2. Alright, so we factored it. Can that help me find wherever these strange x-intercepts are? And you can, because you know what the y value is at these points. Y value at the x-intercept is always 0, so go ahead and plug 0 in for y. So we've got x minus 5 and x plus 3. Again, we're going to use the zero product property to find this, which means that two things that multiply together equal 0. That means one or both of them has to be 0. So that means this one could be 0, so I could have 0 equals x minus 5, or this one could be 0. And remember, try not to get tripped up on this. This is an entire number here. That's a whole number. We just don't know what it is because there's an x as a part of the number. This is also a number. It looks weird because it's got two parts, but it's just one number once you know what x is. And then you can just solve by adding 5 over here, which gives you x equals 5 as one x-intercept, and x equals -3 as the other x-intercept. So once we have that, we actually can get a pretty good look at what this parabola is going to be like. We can go ahead and do a quick sketch of it. I know that I'm going to have an x-intercept at 3, or -3 and 5. So I'm going to go ahead and put my points in. Okay, so that's your first step here. But we also need to find the vertex, and that's kind of tricky as well because I didn't tell you the vertex form, which is how you found it in the past. But there's one other thing about parabolas that you know. It's that they're symmetrical. They're exactly the same on both sides. So if you see the x-intercepts, that means that the vertex has to be directly in between these. Now, when it's whole numbers, sometimes it's pretty easy to see here. And in this case it is. You see that the positive 1 is directly in between. So wherever the parabola happens to be, we know the vertex has got to be on positive 1. Alright, so now we have a really good idea of what this is going to look like, but we don't have specific points yet. We also know that it's a smiley face because the 1 appears positive. That's another clue. Okay? Make sure that you have the correct orientation of your parabola. So the other thing, if you struggle with this, finding these numbers, use the midpoint formula. All you have to do with the midpoint formula, if you have -3 and 5, add up your numbers. So -3 plus 5, and divide by 2. -3 plus 5 is positive 1, or sorry, positive 2, and 2 divided by 2 is 1. Okay, so if you ever forget or you're having trouble figuring it out, or if it's like a fraction or something, just add them up, divide by 2, it will give you your midpoint. Alright, so if I know that the vertex is here, what I really know is that the x-coordinate of wherever this is down here is positive 1. I don't know the y value yet. If I want to find the y value here, whatever this happens to be, I can plug it into my equation. You can plug it into the factored form of your equation, or you can plug it into the original. I tend to plug it into the original, but they're the same difficulty. It doesn't really matter. So if I want to plug it in here, 1 squared minus 2 times 1 minus 15 is going to give me my vertex. 1 squared is 1. Minus 2 minus 15. Put that in your calculator and you get -16 for y. So that means that my y coordinate of my vertex is at -16. Alright? And just like with the vertex of a vertex form, once you know the vertex, you can follow the same pattern of the parent function. So since this has a value of 1, that means that it's the same pattern that we saw in the parent function yesterday. When I move over 1 from the vertex, I go up 1, which also tells me my y-intercept has to be at -15. And again, another way you could check that is to make sure that it matches with this number here. Now, the y-intercept in your standard form is always going to be that last number. So we went over 1, up 1, over 2, up 4, over 3, up 9, and I'm just sketching here right now. And we would go over 4 and up 16, which is why we get there. So here's my parabola, and I have all those points clearly marked with my sketch. But that's essentially what I want you guys to be practicing today. This same process. Can you factor it? Can you find the x-intercepts? Can you use it to find the vertex? Okay. I am going to teach you one more shortcut today, though, that will help you when you get stuck, particularly when you want to find the vertex. So let's look at one more example here and see if we could find the vertex of this function. And I'm not giving you anything particularly challenging right now, but this next process will allow you to solve some more challenging ones. So we got x squared plus 8x plus 7. Now if I want you to graph this one, again, it's in standard form, so there's not much that you're going to be able to tell about this right away, other than it's a smiley face, because there's a positive 1 here, and that the y-intercept is positive 7. So you can get a little sketch of what it might look like, but that's not going to help you too much. You're going to need to factor it to get a better idea. Find those x-intercepts. So let's go ahead and factor it. Again, this is an easier version, looking for two things that multiply to be 7 and add to be 8. Everything's positive, so I know they're both pluses. And by the way, you can hit pause and try this on your own if you want to. I'm going to give you a shortcut at the end. 1 and 7. Okay, so I can then set this equal to 0 to find the x-intercepts. I could say 0 could equal x plus 1, or x plus 7 could equal 0. Subtract 1 from both sides here to get negative 1. And I could subtract 7 from both sides to get negative 7. So I've got my x-intercepts here. So there they are. I'm going to go ahead and put points at those two places. And once again, we want to find the vertex. It's going to be halfway in between. So halfway between negative 1 and negative 7 is going to be right here at negative 4. And you can try that by using the midpoint formula. Negative 1 plus negative 7 divided by 2. That's negative 8 divided by 2, or negative 4. So I know wherever the vertex is, that is going to be on this line, and that the x-coordinate is going to be negative 4. I don't know the y-coordinate yet, but I can plug it into my equation, plug negative 4 in for x, and solve for y. So I could show you, I'm going to use the factored form this time, just to show you that it doesn't really matter which version of the equation you use. It gives you the same answers. So I'm going to plug that in. So instead of x, I'm going to write negative 4 plus 1 times negative 4 plus 7. This gives you negative 3. This gives you negative 3, or positive 3. Negative 3 times positive 3 is negative 9. So my y-coordinate is negative 9 here. Once you know the vertex, you can follow the pattern. Again, this is a value. The number next to x squared is 1. So it's the exact same pattern. Over 1, up 1. Over 2, up 4. Over 3, up 9. And you get yourself the same classic parabola shape. And notice we could check with our y-intercept being 7, it should be up here. That seems to match. So we're looking really good there. All right, now I'm going to show you the shortcut here. The vertex of this one was at negative 4. You can actually find that from the standard form equation as well. There's an equation for the line of symmetry, and I'm not going to show you where that comes from just yet. We're going to learn that later, but I'm going to give it to you now because I think it's just a very useful thing to be able to do. Oh, you guys enjoying the view of my pantry here? Sorry about that. This is a basement, so apologize. And in case you're wondering, yes, this is a gaming headset, and I'm running off a gaming computer, so don't judge me. Yes, I'll beat you in whatever game you think you're good at. Anyway, so here's your shortcut. Standard form equation. This is the equation for the line of symmetry. Now remember, every standard form equation can be written like this. Y equals ax squared plus bx plus c. Okay, and remember, a, b, and c, those are always numbers. They could be 0 and we don't write them in. That's fine. But they are always numbers here. If you find the b value and the a value, whatever they happen to be, you can plug them into this equation. The line of symmetry is going to equal this. Negative b divided by 2a. And that's something I'd like you to have in your notes. It will help you find the line of symmetry very, very quickly. Sometimes they call it the axis of symmetry. I think it's a terrible name. It's a line. It's not an axis. There's an x-axis, a y-axis. This is a line of symmetry. And let me show you how this works. So in this problem here, the a value is 1, and the b value is 8. So we can plug that in here. So b is 8. Notice the negative is still there. Whatever your b value should be in parentheses. Sometimes you can have a negative and then a negative 8 over 2 times 1. Negative 8, or negative, it's a ninja 1 right here, so negative 1 times 8 is negative 1. Negative 8, I can't even do math right now, sorry. Negative 8 divided by 2, and that also equals negative 4. So I know that the x-coordinate of my vertex is negative 4. And you don't have to cut the factored form in half. In fact, if you use this shortcut, you can find the vertex without even using the x-intercepts, which is pretty cool. So you can go directly from here because you can jump from this point all the way to here and go directly to the vertex. And once you find the vertex, you know the pattern. Pattern that we've been talking about all chapter. Again, it's the whole concept of having the parent function with the same exact numbers each time. So once you find that vertex, you're good to go. So it's a shortcut where you don't have to factor first. Though factoring is a great way to check your work, it doesn't take too long to make sure you have your x-intercepts right. And we can even check it on this other one as well. The bonus question from last night, we can use negative b over 2a in this problem. So negative b, remember it's just the numbers we're talking about here. We're not talking about the x's, are always just x's. The b, a, and c are just numbers. So that's a negative 2. And this is 1. Sometimes we call those numbers constants. X is a variable because it can change, it can be anything, but constants are going to be the same number throughout the problem. So negative 2 and 1. Let's plug that into negative b over 2a and see what we get, and if it shows up to give us the exact same line of symmetry. So negative b over 2a, that's our line of symmetry formula. So negative times negative 2 over 2 times 1. Notice again the negative is still there. Be really careful. It's a very common mistake to just have that evaporate on you. Negative negative 2, that's a negative 1. Remember, times negative 2 is a positive 2, divided by positive 2, and that gives you 1, which was what we found for our vertex as well. Okay, and again, this always gives you the x value of your vertex. Okay, so it's a shortcut. So you can actually use this to find your line of symmetry and your vertex right away, and you don't have to go real crazy about it. So I'm going to give you some problems to practice. They'll be on a Google assignment as well. This is going to be helping you do them. So again, just like last time, just upload your work into Google Classroom, and you can think about it like a homework sheet. I do want you to be checking your work and asking questions. You can also, one other piece of advice, I know a lot of you work together on this. That's fantastic, and you can still do that over distance learning. You guys can create your own Google Meets and your own Google Hangouts using the district stuff that's all set up through the district. So don't be afraid to try that on your own. Work together. You can actually share your screen as well. It's going to look kind of similar to what you're seeing here. So you guys can take a picture of what you're looking at and talk about it together and say, how do we do this? I would really recommend that you try that if you're getting stuck on any of this. And anyway, I hope you have a wonderful day, and I'll see you guys during class, hopefully.